Welcome to our next lesson in sets. So, a set is a well-defined collection of objects which are called elements of set. So, we have seen in the previous lesson the set is usually denoted by capital letters and elements by lowercase letters. Sets are represented by two methods. One is roster or list method where each element is put in brackets. So in set builder or characteristic form, we describe this character, a set of natural number x, where x is defined as a with some character, natural number less than 9, or it is alphabet like that. We define x. Next one, if x belongs to set A, we denote like. So we denote like this. X belongs. We put something like that. E. That means x belongs to the set A. So this is a new thing now. Later, x belongs to set A. So in the set, we check this x is there. Next, if the elements of a set are finite, so we are different character of a set. Different characters we mentioned like this. Now in this first one we have telling it is belongs to set A. So if there are set A, B, C, if something belongs to, we say this X is belongs to set A or set B or as a condition. So we put like something like E. We put like this. If the elements of a set are finite, sometimes infinite. Suppose say a set of natural element, it is 1, 2, 3, 4, like dot 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 we write. It goes on. So this is infinite. If we say it is less than or equal to 10, then it becomes finite. So we denote when you say number A, the number of elements in the set is denoted by number. Number in set A, or you say number in set B, number in set C, like that. This number we denote like this. So this number is denoting essentially. Suppose we want to determine how many numbers are there, how many elements are there. Next, if any two sets have equal number of elements, they are called equivalent. So we classifying different sets, equivalent sets. In some case, it may so happen as a set A, there are 5 elements. There's another set B. So all the elements of A are available in B and something more also. So we say A is a subset of B. So we can, one set is given, we can form many subsets. So when we say subset, A is a subset of B. Like that we denote. A is a notation is subset of. That is the meaning of it. We say null set. What is this null set? A new word is introduced. A null set is a subset and unique. So one set is that A. So we say this has got one null set, he says. Null set means no elements are there. It is just like 0. We introduce one null set. Null set is used for certain calculations that we will come later. The set of all subsets of a given set A is called the power set of A. So how many sets are there? Suppose say we have got some 20 elements. We can make many subsets possible. We can take only 2 at a time, 3 at a time, 4 at a time, 5 at a time, or different combinations. So how many subsets are there? So it is determined by the formula subsets are 2 to the power n minus 1. Number of proper subsets to A is 2 to the power n minus 1, where n is the number of elements. Suppose you have got 1, 2, 3, 4. So we can say 1 is a subset of A. This is A. 2 is a subset of A. 3 is a subset of A. Like that we can go on to 1, 2. 1, 2 is another. So we can say 1, comma 2. This set is also subset of A. We say 2, comma 3. That is also like that. We can write 2 to the power n minus 1. That much of different combination we can try. We have seen some of the set consists of all elements which belongs to A or B or to both is called union of A and B. This we have seen the first data. So A union of A and B. A union B. So we add all elements together. A and B. Intersection of A and B is denoted by A and B. Is called intersection of A and B. So we have seen different properties of the subsets now. So this in this one point we have now A minus B, A set divided by, so X means X is belongs to A, comma X not belongs to B, A minus B. That's all. We read like that. The reading is important. If A is a subset of B, this means subset. B is a subset of A. Then if it is the other way also, then A is equal to B. If A minus B is equal to null, null set means nothing common. And it is a disjoint, then set within the two set there is no link. So we have seen universal set is a combination of all sets. It's denoted by mu. Generally, this is a notation. Mu means this is called mu. We introduce this word. Okay. Set A cross set B, whatever set that is given. Or if you give this X, set PQ then set P. We write set P plus set Q like that. This component total is called is represented by mu. Mu means universal total set. What we are dealing. So the formulas we want to repeat and people remember. If A, B, C are three sets, so we can see if apply the same law, idempotent laws. What we call it? First idempotent laws. A union A is identically equal to A only if A is union A. The same elements to repeat is identically is equal to A only. Now, this is associative law. We have seen the last one A union B and then union C is equal to A union of B and C or B union C. Similarly, A intersection B and then intersection C is equal to A intersection B and C. Intersection C. So commutative loss, identity loss, commutation loss also we have seen in the last lesson. A union B is equal to B union A. A intersection B is equal to B intersection A. So what is identity? So A union null set is this. Null means it is nil. Null, nothing is there. So A union null is A. A union mu. This is mu. What we call mu means universal set. So we write this mu is, we write like this actually, is universal set. Universal set means combination of all sets, So A again universal means is equal to U. M only. M is, this is like actually like slightly like this. We write like this. This is mu. We write like this perfectly. It's called mu. So A or null. Is this when you use or, then we get to null only. This is A or mu is equal to A. So A is there. A is common. A is what are all the elements are A is available in the set mu. Mu is universal set. So we have seen this distributive and complement class and demarkant class. So demarkant class we have given two more now. The first two last we have seen. See the sign change. A universal B dash is equal to A dash is equal to or B dash. This is so this is all distributed class in D Morgans. This class we have to practice. A minus B union C is equal to A minus B or A minus C. That way also we can write. It's law of set inclusion we will see. So A is a subset of A. If A is a subset of B and B is a subset of C, then A is a subset of C. That's the meaning of this. This is subset of this is C. Like that. This is a subset. You actually perfectly write like that. C, right? Bigger. And you fall like this, So subset of C. So A minus B means A or B dash. So this is some of the properties of null set are reflected here. This is about number of elements in A plus number of elements in B is equal to number of elements of A or B plus number of elements of A union B plus number of elements of the intersection of B. Next is number of A minus B is equal to number of elements in A minus number of elements of A or B. So this the law of, So in the mu, what is the number of elements is Na plus Nb let us check the number of elements A plus B is one is number of elements in the union and intersection. Number of elements A minus B is equal to number of elements in A minus number of elements of A and B. A union B. These formulas will be, when we do more problems, will be more clear. Thank you. Now we will work some problems connected with this in the next lesson. Thank you. Please repeat the formulas so we'll be familiar to understand what is the union, intersection, subset, null set, what is that mu, universal set, and this additions idempotent associate law that we normally get apply in all the arithmetic problems. So while doing the problems, we will be remembering certain things. Thank you.